The exam review, Wednesday, April 24th, 8:45. Alright, class starts at 8:35. We'll start the test at 8:45. Make sure everybody gets in here, gets settled, answers any last minute questions. You have an hour. Ooh, just an hour. 39 questions. The vast majority of your test looks very, very similar to your quizzes. So as much fun as I had giving you the kind of story problem for your last final exam, you guys like it, you nailed it. This is just going to be like your quizzes. It's going to be a boring test. It's going to be like your quizzes. Very, very similar to your quizzes.
Very, very similar to the point of like...
I mean, if you see some questions that look identical, I hope you studied. It won't be identical, but there may be some identical questions. For those of you who are diligent in studying, you may find it not as difficult as it's not a tricky test. I mean, the questions are fairly straightforward. I've used this test with other groups. So I've validated the items, I've taken out the bad items, I've put in better items. It's a pretty straightforward test. Yes.
So does the Saturday class have it yet, or will that be next Saturday?
So they have it next Saturday. But they will have it before you do, so. No, you'll have it first. You'll have it first. Last Saturday class, Saturday and Wednesday both had it. The only thing I've done is I've changed the question about having to actually calculate the false positive and false negative rates. Threw that one out because of the conversation we're about to have. But yeah, it's pretty, like I said, the questions aren't, it's a very straightforward test. That's not a tricky test. The hardest part about this test is that it's comprehensive. Okay? It is comprehensive. It's everything from lesson 1.
Lesson 2.
Well, no, lesson 1, 2. I'm trying to remember if there's text mining on it or not. I don't think there's text mining on it. So I want to say it's lesson 1 to lesson 11. There may be a text mining question, but it's not big if there is. The questions are fairly well distributed. So if you're like, oh, please don't want to be a question on neural networks, there's probably going to be 3 or 4 neural network questions. But the great thing is there's probably only going to be like 3 or 4 neural network questions. And if you're like, oh, decision tree questions, there's only going to be like 3 or 4 decision tree questions. So it's fairly distributed. There's not one topic that's weighted more than the other. A lot of the test is general overview questions. Right? So there's a lot of, here's a list of data mining tasks, which is appropriate for a k-nearest neighbor, which is not appropriate. Here is a algorithm. For this algorithm, what is true, what is false? Right? So let's select all the apply things. A lot of it is synthesis. Right? How does multiple regression compare to linear regression? The good things and the bad things about neural networks. It's just kind of a general knowledge test. So the questions are fairly straightforward. The downside is that it's just a cumulative test. So it's on Wednesday, you've got an hour, just like your quizzes, mostly multiple choice, a few true false, a couple of short answer. Now there's going to be one calculation. You're going to know how to do the association calculations. And the next few slides that I have are really just reminders of things. So I figured I'd go through them rather quickly, and then when you guys have questions, just stop me. Okay. Making sure to know the vocabulary. If I say, give me a task, don't tell me one of these things. If I say, give me a methodology, don't tell me one of these things. Right? Give me the right thing that I ask for. Knowing the steps in the CRISP process, you don't need to know the details of them. But if I say which of these 5 things doesn't belong, you should be able to pick one out. Same thing with sigma, right? You don't need to know it all in detail, but if I put 5 different words up there and say which one doesn't belong, or pick the ones that do belong, you should know what it means. A lot of questions, several questions on, is this categorical, or is this supervised, is this unsupervised? Of the following, which ones are or which ones are not supervised methodologies, right? That kind of stuff. If I give you a scenario, can you pick the right task? You're definitely going to see 2, 3, 4 questions about that. Here's a scenario. Just tell me, is it an estimation task? Is it a classification task? Is it a clustering task? So going back to quiz 1, quiz 2 on this stuff. Knowing the difference between model-driven and data-driven. We have 2 that are model-driven. Which 2 are model-driven? Linear logistic regression. That's it. Everything else is data-driven. We only have 2 model-driven. Again, kind of identify and match the data mining task to the data mining methodology. So if I put supervised and unsupervised, could you play matching games? Approaches to variable reduction. And some of this stuff, there will be some software questions on here, not a lot. But how would you do variable reduction? You guys have been talking about important variables this whole time. You guys talked a lot about important variables today. How did you decide that? Where did it come from? What did you do? Know what principal components analysis is. The really great thing for principal components analysis is which data mining methodology does principal components normally come with. K&N. See, you're doing good. Alright, you're getting higher and higher. Knowing how we assess models. Right, so, error metrics. I'm not going to give you the crazy questions. Right? But if I give you a misclassification rate, can you tell me which model is the best based on the misclassification rate? If I give you the tables, like what you guys did today, could you convince me which model is the best and why? Okay. And that may include misclassification rate, false positive, false negative. It could include any of those things. If I give you a list of fit statistics, can you tell me which one belongs with estimation and which one belongs with classification? Right? So, true or false? The misclassification rate is the best metric for an estimation task. Best one toward a classification. I'm not going to make you calculate error rates because that's just confusing at the moment. What's overfitting? How do you detect overfitting? What's a couple of ways you can detect overfitting?
Big differences between training and validation. Makes sense.
So we don't want to see big differences between training and validation. And so the way that you prevent it is by using the validation data set and checking for it. Prevent may be a strong word. Yeah. This is the craziness of life. This is what your textbook says. You go and look on the internet, you're going to get one answer. If you guys did your own math, you guys have other answers. So, talking about false positives and false negatives, from what I can research, and I will continue to research this to try to have a better, best answer. Different books, everybody's pretty comfortable with sensitivity and specificity. Everybody pretty much agrees on what those 2 formulas are. The proportion of false positives is this formula right here. Some of the research that I did, so this is called the false positive detection rate, as opposed to the false positive misclassification rate, which if you look online, you'll see is false positive divided by false positive plus true negatives. There's several different formulas. It's all about how are you doing it and what are you interpreting. So as long as you interpret the formula or interpret your results correctly, I'm okay with any of these formulas. Because this has become kind of an issue, I'm not going to test you over it. Because that just seems mean. But we will have a little bit more of a conversation. So as long as in your paper, if you talk about false positives, false negatives, make it clear what formula you used. I don't care which formula you use. Some of you have been saying, here's the misclassification rate, it's 20%. Well, 15%, or well, let's do it the other way, 60% are false positives and 40% are false negatives. So of the 20%, when you're looking at it that way. So you're actually looking at the percent of misclassification rate that is a false positive. That's a fine metric too. You just have to be able to explain that that's what you're talking about. Again, not going to touch you. Just because it's... The rest of these slides you're going to see are very, very similar. The only thing that changes is the methodology. So again, just big, overwhelming. We started out with just knowing is it supervised, is it unsupervised. We kind of already hit all that. I'm not going to make you do any standardization calculations. It's one. You may see some different graphs, because we talked about visualization. Okay, so if I give you a graph, can you tell me which graph works best for doing whatever I want to do? I wouldn't spend a lot of time on that one. A lot of what you're going to see, like I said, are going to be, can you explain how linear regression works? I don't expect you to be able to give you all the dirty details. You're not going to have a essay, please explain how linear regression works. But if I give you some of the key things in a multiple choice, linear regression has, or focuses on the nearest neighbors. True or false? Does linear regression focus on its nearest neighbors? No. Okay, nearest neighbors focuses on the nearest. Do not overthink this. If it is that obvious, it is that obvious, right? So, but it'll be questions like that, or it'll be a multiple choice that says it'll either be a select all and apply. A lot of times, what you'll see, if the answer is choose or all of the above, if two of them are right, just assume the rest of them are right too. So, kind of big picture, how does it work? What metrics do we use to assess it? ASE, root mean squared error, or misclassification rate. And if I give you some output, could you tell me something about it? Okay, so if I gave you an equation and asked you which variable had the biggest impact, could you tell me? What's the other big things? We did the same thing for logistic regression. Big picture, how does it work? What metric do you use? Talk to me about advantages and disadvantages. And again, I'm leaving this is very broad, right? Go back to the slides, you'll see there will be slides that have advantages and disadvantages. I took that question out because I really have worked to make this a pretty forward test. Same thing for K nearest neighbor. Some things to think about, right? What does K represent? Can you determine K? What happens for, what's the difference? Why would you choose a low K versus a high K? Okay, it says low misclassification rate. When you have a high K, you're looking at a lot of neighbors. Do you get the big picture, or do you get the stuff that's really detailed?
Big picture.
A high K, you get the big picture, but you miss some of the local detail. With a small K, what do you get? You get the local picture, but you may miss the big picture. Right? Another fun question, and this could be a choose all and apply. Of the following methodologies, which must you prepare your data? Which of these require you to standardize your data before you begin? K nearest neighbor, clustering. Where else do we have to standardize our data? Naive Bayes has to be classified. Neural network. Alright. So of these, and maybe of these, which one do you have to? If I ask which one do you not have to standardize your data for? Decision tree. We love our decision tree. It'll take anything. Okay, but those are the kind of questions you can expect to receive. Right, so big picture, just big picture, how does it work? What are the big key things that we're talking about? How would you assess it? Again, we shouldn't be standardized or normalized. Decision trees, how does it work? Big advantages or disadvantages? The structure of the tree, right? So if I use the word leaf, I would expect you to know what leaf means. So all of these are posted for you guys to look at. Association analysis, this is the one for calculations that you'll need to be able to do calculations. Yes.
So explain theory and entropy.
I kind of skipped over it because we didn't really talk about it.
There's 4 of them right on the slide.
There's 4 of them on, there's 4 of them on a slide. And just the different splitting criteria that we used. We didn't get into it a lot because we used our visual analytics, we use VIA, not EM.
Yeah, so I just want to make sure not be distracted.
No, I kind of just skipped over that for a reason. And that's one of the things I've had to go back and look at there's stuff that I focused on last semester or last year that we didn't hit as hard because we did more VIA stuff, so I've had to same thing, so association analysis, be able to calculate it. If I ask you which rule should you choose, tell me which rule you should choose. When we do association analysis, do we get just a few rules or do we get a lot of rules? A lot of rules. Are they all good rules?
No.
So being able to pick the right one, knowing the difference between support, confident, and lift, and being able to calculate it. So if I give you something like this, do you guys have one of those on your quiz? Calculations on your quiz? Maybe? You'll go back, you'll look at it, you'll be like, oh yeah. Yeah. I don't know. Well, if you didn't have one on your quiz, you'll have one on your test, so make sure you know how to do those calculations. The naive Bayes, what's the big thing about naive Bayes? It's different than everybody else.
Input also has to be categorical.
Everything's got to be categorical. Everything's got to be categorical. If we don't, so that's kind of the same idea. Here's more specific questions. So basically, if we have interval level predictors, then we have to bend them to make them categorical so we can use them. Commonly implemented network algorithms. This is probably one of those where I'll have a list, which of the following are or are not. Do me a favor. If I make a question like this, and I have like tan and Markov blanket, and I have words that like make sense, and then I have something like, I don't know, it doesn't make sense. Like, what is a commonly implemented Bayesian network algorithm? And I put, somebody throw something in
Mortal mechanism.
Douglas decision tree.
there you go, the Dr. Douglas decision tree, whatever. Can I throw in a weird, don't pick that is. Sometimes you just need to relax and you're like, well, and I do silly things like that. I'll do it. Okay. If the question seems obvious, like the answer's in the question, the answer is in the question. Just go with it. Don't overthink this. Alright, explain how the neural network works. So kind of those big ideas, you know, what is feed forward, what is fully connected, that type of thing. And there we go. Which one should you pick? So you have assignment 9 that's due. You also have assignment 10 that's due. I'm sorry I gave you 2 assignments due at the same time. But remember, all assignment 10 is a concept map. You can make it very detailed, or you can make it very simple. Concept map. Ready? Data mining. Structured. Unstructured. cluster. I mean, write in some more words. Association. No, you can't use mine. Right? Linear regression. Or maybe
I'll close out the center circle.
maybe categorical. Continuous. You got a couple things coming off of there. It doesn't got to be crazy. Okay. Use whatever software you want. You can draw a picture of it and just send me that. Whatever works for you. Yes.
This will be due that same as assignment 9. If I didn't say it.
Yeah. Because really, again, the whole idea behind doing the concept map is for you guys to have it for your tests. Right? This is your study aid. So as you're studying for your tests, do this.
Yeah, that's true.
Whatever studies for your test, whatever makes the most sense for you, that's what I need you to do.
Okay.
You'll turn it in. It's nothing crazy. You have questions, ask me about it. We've made all of our decisions. And we're good to go. I kept you 2 minutes late. I apologize. But if you have questions, stay and hang out. If not,
We allowed to just like have a laptop with us if I know it's Good job.
Mackenzie small.
Wait,
It's like that.
we can have like a mental study.
you can use whatever you want on the test.
Oh, putting notes? Except for what? Except for
So is everyone here that it's open notes? So funny there.
What? Are you eating now? I mean, we are. I've got to go meet Jeff for a few minutes. Hop over.
No, I'm coming right
Send it. Then you're finding out what's happening.